So I think this first example is really interesting, which is a GoPro mount for a motorcycle helmet. And you may laugh at first, but I don't just think this is cool because I made it and it's for my helmet. The reason I think it's interesting is because the problem it solves is a really good fit for 3D printing. And in fact, there's already a company out there that's sole purpose is making these for different helmets, and they're using 3D printing to do it. So the reason it exists is obviously to put a camera on a helmet, and it gives you that really nice point of view, but it's 3D printed because every single helmet out there has different curvatures to it and different shapes needed. So for example, this one has a curvature in one direction and a different curvature in a different direction. And then on top of that, manufacturers come out with new models every few years to replace the old models. And so there's this humongous variability in the shapes and sizes that these need to be to fit onto helmets. And the existing GoPro mounts that you get with the camera don't typically work with whatever curvature is on the helmet. And so maybe you can find a spot that it would work on, but then you're using a bunch of these different adapters to get the camera positioned correctly. So 3D printing is great because it's so easy to get that high variability between parts with basically no effort required outside of adjusting your CAD model, which you would have to do anyways if you were manufacturing this part traditionally. So it's also a great fit because you're not going to end up with a huge overstock of parts that get outdated. You can essentially make these things to order, and you can do hundreds of the same part if that's what the demand is, or you can do different parts, hundreds at a time of each of them for different helmets in the same build with the same machine and the same footprint. So no storage needed for multiple injection molds and all the associated tools. It really simplifies things for this workflow. So before I keep going on that tangent, let's go ahead and set up a few of these within PreForm, and I'll show you how to do a few hundred. So here's PreForm at a glance. We have our build chamber for the fuse laid out here, and we can start putting our parts inside of it. And then on this side, we can select the type of printer we're using, the material we're using, and then we can start to play around with our print settings. The speed optimize setting for this part is going to be no problem because it's not a super complicated part, and that actually controls the way that the laser lays the part out. And so again, for relatively simple models, the speed optimize is no issue. So now the next step is to just drag and drop our STL file. And then I'm actually going to drag this thing into the corner over here and start using the tools in PreForm to build out our full build here. So one of the most convenient ones is this Array Models tool. And so this starts expanding out in all 3 dimensions. And by default, they give you this 5mm spacing, which is super safe, but we can go as low as 1mm here with no issues. So I'll go ahead and do that in the 3 directions. And then this is the way I like to do it. Expand it out and see, okay, we've still got a little bit of room here. So I'll go ahead and add an extra millimeter just to be safe. And then same thing in the Y direction. Got a little bit extra, so I'll expand it out one more. And then let's grow up in the Z. And let's see how much space we have there at the top. Same thing, we've got some space there. So I'll add a little safety buffer of 2mm. And now we've got 320 of these models built out in our chamber here. And calculating the time for these can take a little bit, so I went ahead and pre-calculated it. So we've got 16 hours to print 320 of these things. And after 16 hours, we can go ahead and pull this chamber out, put a new one in, and kick that next one off. And we'll leave this chamber, the first chamber, cooling for 13 hours, 14 hours in the sift. And once it's ready, we can go ahead and pull all these parts out and they're ready to go. Our packing density is 40%, so we're golden there. We're above our 30% refresh rate. And so we're gonna be able to have a really good refresh rate going forward, and we're getting good quality parts. So the total powder used is 5.42 kilograms, but the number we're actually kind of concerned with here is 2.17. That's the fused powder that actually becomes part. And I did these calculations beforehand. The fused powder comes out to $216.64 roughly for this whole build. So we divide that by our 320 parts, and we get about 68 cents for each one of these things. And I've seen these things go for $20 or $30, so we're making pretty good profit here. So again, a pretty cool example of this, and a good one for SLS. But let's take a look at a couple other things now too.